All right, so let's go over this warm up. So this is simplify square root of 800. A lot of you guys went straight to the calculator to check. That's fine, because you know why? It may be a perfect square and you might get a nice pretty number. But if you go to square root of 800, you get a decimal, right? If you get a decimal, then you have to do that factor ladder or the factor tree thing to simplify this, okay? So if we break down 800, right? And you know, and I simplify it a little bit differently. I just put everything inside and I see what I can bring out that's the same. So 800 is what times what?
400 times 2.
I mean, there's so many different combinations, but you could do 400 times 2, right?
100 times 8.
So with 402, or 400 times 2, okay, that 2 is a prime number, so I'm just going to bring down the 2, right? Okay. Now I need to break down this 400. This 400 breaks down to what times what? Okay, all right, 2 times 200. Sure, we could do that. Okay, yeah. So now you have these two 2's that are prime numbers. You need to break down 200. So I'm just going to circle my prime numbers so that I know. So I have 2 and 2. Those came down. Yeah? And then 200 is 2 times 100. Yeah? Okay. So you know what? Now, guys, so now we're going to, you know, it's just going to take forever if I just keep bringing it down to the 2's. What do you know about 100?
It's divisible by 5.
Well, it's also a perfect square, right? Isn't 100, what's the square root of 100?
10.
10. That means you can break down this 100 to 10 times 10. All right, so let's see. I have 1, 2, 3 2's that I need to bring over. 1, 2, 3. Yeah? And then this 100, we said it's a perfect square, breaks down into 10 times 10. Yes? Well, you know what? I could break down each of those 10's, but why? Because what I'm looking for are 2 of the same, right? I'm looking for pairs. So right here, I have 2 10's. So one of those can come out. Yeah? I have 2 2's. So one of those can come out. What about this 2 that's left over? Stays inside. So then this, if I clean it up, what's 10 times 2?
20.
20. So 20 root 2. And you know what? Here's another way that you can check just to make sure that you did this right, okay? You can go to your calculator. Let's see, if I did square root of 800 and I get a weird decimal, right? It's fine. Put in your simplified form, 20 root 2. Do you get the same thing? Yes. So that's how you can also kind of check yourself and make sure that you simplified it correctly. Okay? All right, so let's look at number 2. Okay, so solving absolute value inequalities. Remember, whenever you have absolute value, you're going to have 2, right? So the thing you need to do here is you want to get this absolute value all by itself. Get the bars all by itself. So what do I need to move? Yeah, subtract that 7. So now you have the absolute value of x minus 4 is less than what? What's 15 minus 7? 8. Okay. So then now, as you would with equations, absolute value equations, right? You drop the bar, you write it twice. The first one looks exactly the same. Same inequality. With the second one, what do you need to do to the sign?
Flip it.
Good. What do you need to do to this 8? Yeah. Okay. Why do I, huh? Well, that's the rule that we talked about, right? So, you know what? So, here's the thing though, guys, with inequalities, it's either going to be an and or an or type of situation, right? Is it or? Sure. What is this? That's less than, right? And, but you can also go and graph it later just to make sure it works too. But this should be an and graph. So that means that they should be connecting, right? There's no going to infinities here. All right, so if I solve for these x's, so add the 4, x is less than 12, and the 4, x is greater than negative 4. If I graph this, let's see, negative 4 is over here and 12 is over here, yeah? What kind of circles do these have? Open or closed? Open. X is greater than negative 4 and less than 12. Look at that. Oh, it's an and. Yeah, I mean you can kind of graph it just to make sure, you know. But it didn't say graph, so you don't have to graph. It just went. Huh? Yeah, absolutely. Okay. All right. So any questions about this?
Wait, so then how's it written?
How's it written?
In
So
the curly cues.
here.
In the curly cues.
Huh?
So that's how it's written in the curly cues.
Oh no! If you want to write it as a well, in the curly, so we would say like if you want to write it in set filter notation, or if you want to write it in like interval notation. So if you're doing set filter, you would say x such that x is less than 12 and x is greater than negative 4. Yeah? Just your answers with the and or, okay? If you're writing this in interval notation, then you would say negative 4, that's where your graph starts. Open circle, all the way to 12, open circle. Okay?
So you wouldn't write it with the x in the middle, with the three things and the x in the middle?
So it's
Oh,
not.
no, you could, because it is an and. Yeah, you could say, so here, you could also say negative 4.
Yeah, that's what I would.
Yeah, you could do that. Oh,
Does it
wow.
have to be
Making
in
me
that
work
order?
today. That's nice. Good.
Does that have to be in that order, or can it be switched?
It has to be. If you're doing these signs. All right. Okay, so any questions about the? All right, so day 1 in unit 5. Okay, we're going to talk about something called nth roots and rational exponents. Okay.
This looks evil.
So rationals, right? If we say rational exponent, you guys should automatically think fractions. Rationals is like ratios, fractions, right?
Oh.
So you're going to have fractions in your exponents, okay? That's basically what we're going to be talking about. So this means that you could have something written this way, right here, okay? You could have the rth root of x to the p power, right? But you can take that and you can rewrite it so the x comes out. You have x to the power over r, okay? This r is your root, but is also called the index, all right?
I really hate it when you give us new words.
I know, it's all that vocab. Math is vocab.
It should have.
All right. And so, you know, another way to kind of remember this is power, right? We think of exponents as the power. This r, you think of it as the root, yeah? So then this is x to the power over root, power. Okay? All right, so the first couple of problems is all we're doing is rewriting it. Let's just rewrite the expression using rational exponent notation. We're turning these into fraction exponents. So remember, power over root. Okay? So you have 33 that comes out. Guys, what is the power on this 33?
1.
What is the exponent? Yeah, 1, right? And what is the root? 5. Okay. That's it.
Is that the answer?
Well, all we're doing is rewriting, so we're going to stop here. Okay. So let's try number 2. What is this? 5 to the 2 thirds. I see what you're saying. So it's okay. It's okay. Yep. All right. Questions? It's the easy stuff. All right. It says rewrite the expression using radical notation. Now we're taking these.
3's
Oh,
missing.
really? Oh no. Where is it? Oh my gosh. Who decided to put this all the way down here? It's not very smart. No, not me. Maybe it was me. I don't know. Okay. All right. So, okay, number 3 right there. Okay, this is actually a very important one. If you look right here, is there a number for the root? No, but if you just look at that, what would you call that? Square root. What does square tell you?
2.
2. So if there is no number written there, then it's always 2.
So it's 2.
Because it's square root. Okay.
So
this would be x to the what? 3 over 2. 3 halves power, right? Does that make sense? Okay. Now we can go to this. Now we're taking these rational or fraction exponents and we're going to turn them into the radical. So with these, I would draw out the radical first, right? Take that 9 and put it in there. What's the power on that 9? 1. So do I have to write the 1? No. But what's the root?
3.
3. So make sure you tuck that 3 in there, okay? Here's what we do not want you to do. And we see this every year, so we're just telling you in advance. What is that? That's 3 times square root of 9, which is 3, is 9, is what you just told me, right? Like, this is not okay. I think you guys are old enough and we should be good to, show the difference. Yeah? Okay, thank you. Just be mindful. Don't do this. All right? Okay. So what about number 5? Draw your radical. Then what? Negative 243. Okay. And then what's the power on this?
2.
2. All right. Yeah, I'm going to put parentheses. And then put the little 5. You know what? Sometimes no. But, just general rule of thumb, guys. If you see parentheses, put parentheses. Okay? For what we're doing with these, it won't really matter. But later on, it might. So for now, do that. That's what we were talking about earlier. But
Why don't you put one?
I mean, you could, but then you're not going to write the 1 out here anyway. Okay, so let's try 6. Oh, let's try number 6. You guys try number 6.
I did it.
And if you want to try number 7, you can try number 7 too. You already tried number 7? All right.
Button.
Okay. Well, it looks like most of you guys did number 6. So let me just catch up here. X, we had the 3, we had the 4. Yeah? You could do this, or you could write it with the or you could write it with the parentheses, right? It doesn't matter with this one. Here, do X. Okay, but that one's fine. All right? Yeah.
I wanted to ask
Okay. So number 7. So So number 7 is, they're a little bit tricky here because the x and the y, those are the ones that have a rational exponent. Tell me something about that 7. Does that have a rational? No. So does it have to go inside the radical? No. Right?
So it goes outside of it?
Yeah, that just goes on the outside of it.
Okay.
And if you look at both your x and your y, do they have the same root number?
No.
Yes, right?
Yeah.
It's the 7th root. And x has what power?
2.
2. And y has what power?
5.
5. So there you go. Does that make sense?
It's 1150.
Huh? 1150? Okay, fine. All right, so sometimes they're going to tell you to just evaluate, and you can evaluate those expressions using a calculator, okay? Only use a calculator and only give us decimals if the instructions say to, okay? So, calculator steps, okay. If you're putting in a different number root than a square root or a cube root, what you need to do is put your root number first, okay? So put in your root, and then you're going to go to math, number, and you're going to choose the one with the little x in front of your radical. I think that's number 5. Yeah, and then you just put your radical, like the things that are inside your radical, then you just put that in, okay? So let's try this together. Seventh root, all right. So since it's 7th root, I'm gonna put 7. Nope, can't. Okay. Math. Is it number? No, it's 5. Sorry, it's just 5. Sorry. Math and then 5. Cross out number. Excuse me. There we go. Sorry about that. And then it's negative 4,573.
Parentheses.
Sure. Or you could not, because mine doesn't have it. Okay. All right.
I
So
got
there.
error.
What? You got an error? You know what? If you got an error, you probably put subtract instead of the negative. Okay. So go back. Make sure you use the negative and not the subtract. All right? So since we have this, what's this? Negative 3.333. Then it says round to the nearest hundredth. So that's 2 decimal places. So it's negative 3.33, yeah? Okay. Negative 3.33. All right, let's try the next one. So anytime you have fractions, you need to put it in parentheses when you put it into the calculator, okay? So with this one, try to make sure you put, let's see, what was it, 257 in parentheses, to the, right? And then you have a fraction as your exponent, so you need to put that in parentheses as well. So just like I have it up here.
Enter.
Yep, enter. 10,388.56. So with this one, if you need to, make yourself a little note, all right, to the parentheses 5/3, okay? If you don't put the parentheses, what it's going to do is it's going to take 257, take it to the 5th power, and then divide it by 3. And you don't want that, all right?
Will it always come out as a decimal?
For those, yeah. Because, yeah.
Okay.
I mean, I guess sometimes it may not, but I guess if we're saying evaluate using a calculator, it'd probably be a decimal.
Okay.
All right, so it says evaluate the following expressions without using your calculator. Okay, so now we're gonna have to either simplify it, simplify the radical, stuff like that. Okay, do not give decimal answers. All right, so what tells you how many, of the same number or the variables needs to come out?
The root?
Yeah, the root. Good. Nope.
What?
Not
Oh.
Right? The root, or your index, right? That's the number that tells you how many you need in order for it to come out of the radical, okay? So if I have the cube root of 125, do you guys know what the cube root of 125 is?
No.
Huh? It's 5, right? Yeah. If you have your perfect cubes memorized, you look at it and go, oh, okay, 5 cubed is 125. But if you didn't remember that, that's fine. We'll just break it down. Cube root of 125. Well, 125 can be broken down into 25 times 5, right? And 5 is a prime number, so that one that's going to stay. But the 25 I can break down. So cube root of 25 becomes 5 times 5. And then I need to bring down this 5, right? Now I can't break it down anymore, but my root is 3. That tells me I need 3 of the same thing inside in order for it to come out, yeah? So I have 3 5s exactly with nothing left over, so this is just going to be just 5. Okay? Yeah.
The way you're factoring like all these things, not factoring, but like breaking down the numbers inside the radical, it's like slightly different normal. It's different than like previously. Like the way like I thought like it was you had to do the factor ladder, you know what I mean?
Yeah, well, I mean, it's the same thing. Do you want me to do the factor ladder?
Yeah, this like I'm I understand what you're saying.
You're just breaking it down. So I mean, I just am concerned about the space. You know.
Could you show me the way with
Sure, I'll do factor ladder. Okay, so let's look at the 4th root of 432. All right. So 432. If I break this down, what is it? 432. Let's see. Divided by what? What number could I use? 2, so then that's 216. All right, so then, okay, you can just keep using your prime numbers to break it down. 2, and then that's what? Okay, so break it down again. 2, what do you get? 2 again, what do you get? You can't do 2 here, you gotta do 3, so then you get 9. 3, 3, and then 1, and then you stop, right?
So it's 4 times 3 root
Good.
3.
So 4 is your root. That means you need 4 the same thing in order to come out. So here we go. Here's, and then these 3 can just stay in. So the 2 comes out, and then you have the 4th root. What's 3 times 3 times 3?
27.
Okay.
Okay, so if it has a 4 on the outside, that means that 4 needs to come out. Like instead of if there's nothing on the outside too,
Yeah, then you would need 2 of the same thing in order for it to come out.
so say there was a 5.
Then you would need 5 of the same so it to come out.
What happens if you don't get it?
Then they all stay in.
Okay.
Yeah. All right, so let's look at number 12. All right, so if I have 100 divided by 81 to the 1/2 power, Okay, well, you know what? Anytime you guys see fractions, let's see if we can simplify it. So 100 over 81. Can I simplify that? You could even use your calculator. Put in 100 divided by 81. You'll get a decimal. Can you do math, enter, enter?
No, he doesn't.
Okay, so then this to the 1/2 power, well, that's power over root. Do you agree? Yeah? Okay, so then that's just square root 100 over 81,
Sorry.
right? Power of 1, so I'm not going to write that. Yeah? So that looks funny, right? When you have a big fraction inside a square root.
Mm-hmm.
But this is actually the same as if you were to split it up and you said the square root of 100 over the square root of 81. Okay, you can do that. See if that helps you to simplify it.
And you put the 2 in the
I
corner.
don't know.
And then you put 2 on the shelf.
Oh, yeah, but you don't have to write that. Okay? Because if it's not written there, then it's known. It's just this 2. Yeah. Square root of 100 is
5.
10. Square root of 81 is 9. And can you simplify this? That's it. All right.
Oh, so the 1/2 that was at the top.
Mm-hmm.
There's 1, you don't have to write it.
No.
And 2, that just means that it's like straight.
Square root.
Square root, and then split it. So it'd be
All right, so let's try the next one. So we have a power over root situation again. So let's rewrite this. So cube root, and what is this? Negative 125, and then square it. Okay, yep. Right? Okay.
the bottom one goes on top of the row again.
So that's the exponent because that's the power. And then the one on the bottom is your root.
Like
All right,
on the
so
shelf.
you know what? I would try to make the number smaller. Or see, you know what I mean? Like cube root of negative 125. What is that?
5. Negative 5?
Negative 5. Right? Because think about it. You have 3. When you have an odd, you can get a negative number. Because what's negative 5 times negative 5 times negative 5?
Negative
This
15.
becomes a positive times a negative, and that becomes negative. Right? If you have an odd root, you can get negatives. If you have even with the negative, then you probably get odds. Okay? So this becomes negative 5 squared. What is negative 5 squared? Huh? 25. Because that's negative 5 times negative 5, which is positive 25. All right? Question so far?
How do you do the next one?
How do you do the next one? Okay, be careful because this negative is on the outside. Okay, order of operations says parentheses first, right? So do everything inside here. So what is this? 4th root of 256. And then you cube that, and there's a negative on the outside. Okay, so let's do this first. 4th root of 256. Okay. We can break it down. 256, what? 2? What's 256 divided by 2? Huh? 128 divided by 2. Divide by 2. Divide by 2. And 2. 2. 2. 2. And then 1, yeah? How many do I need in a group in order to come out for this one? 4. So let's see. We do have a lot of 2's. So there's a group of 4. And look, there's another group of 4. So what does this mean? The 4th root of 256 is 2 times 2, which is
4.
4. So 4 cubed, and then we still have the negative on the outside. Right?
Mm-hmm.
What is 4 cubed?
Mm,
64.
And then times the negative 1 gives me a negative. Okay? Yeah, you have to do all of this first. If you have a negative outside the parentheses, that goes on at the end. Because this is like saying negative 1 times all of this. Negative 1 times all of that.
You have 2 4s, so you would just put 4?
well, no, 'cause it's
Where?
twos.
Oh, no, because one of these 2's comes out. And one of these 2's comes out. So 2 times 2 again.
He doesn't even have 4 to 2, then why those?
But did you break it down another way? Is that one?
No, I was just confused.
Where?
There's 2
It looks like it should be added up
fours?
to 8.
Like, there's one group of 4 and then another group of 4, so you wouldn't combine them?
Yeah, I did. Oh, but you're only looking for 4 in a group in order to come out. So since there are 2 groups of 4s, then that means that there's nothing left over, and one of those comes out, multiplies with that other one. Am I not understanding?
No.
Okay, we'll come back to it, okay? If your question doesn't get answered, then ask me again, okay? All right, so this part, okay, so we're gonna show you this, all right? But don't worry about it too much, okay? We do have to show you, but we're not going to be super picky about this, okay? All right, so if you have the nth root of a to the n power, right? So you have like these radicals and you're simplifying it, okay? You have to put the absolute value of a if your n is even. If your n numbers are even, okay? And it's just a if your n is odd. So just whatever number if it's an odd, okay? The thing to remember is that it goes even, odd needs the absolute value, okay? So that's even root, even power, odd, whatever answer you get at the end, that needs absolute value, all right? I'm just going to show you, okay? Don't stress out, all right? If I have the 4th root of x to the 4th, right? That's even. What's the 4th root of x to the 4th? Well, 4th root, 1, 2, 3, 4. How many do I need in the group in order to come out? 4. Okay, so then just a regular old x comes out, right? What's the power on this x?
The 4.
No, the one that came out. 1. So it went even, odd. Do you agree?
But why I don't?
Even root, which is 4, even power, which is 4, and when I simplify it, I get just the regular x,
Oh, it's an
which
odd
has an
number.
odd power.
Okay.
So if it's even, odd, this needs to be an absolute value of x.
Okay.
Okay? Yeah.
Why would you use this?
You know, so it's because technically it could be a negative, like negative times a negative times a negative times a negative gives you a positive, right? Or you could have positive, 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 that gives you the same. You know what I mean? So it could be the negative or the positive, but you're saying it has to be the absolute value of the positive because there isn't like an I, like that type of thing there, right?
Because the definition of the square root of 4 whenever you have the even root, the odd part is 4. That's the definition, mathematical definition of equation. So, for example, the root of 4 is always 2. It's not negative. Even though x squared equals 4, we say plus or minus 2. Right? But the square root of 4 by definition is a positive number, 2. And that's why when you have square root of x squared, you need to make sure that you put absolute value of x if you want to be just into the
even, odd means you have to put absolute value, okay? So if you look at this square root of x cubed, and you know, for some of you guys, you might think this is pretty interesting. You have 3 x's inside of a square root, right? So you need 2 in order to come out. Well, you have even, and then you have this even that comes out. So that's why it's absolute value of x. And then you have this one that stays in. You know, and this one might actually be a little bit better if I show it like this. It has something like that, right? So then when this comes out, but you still have this guy left over. All right? There are some examples of not even, odd. Look at this, 3 cube root of x cubed. That's odd, odd, odd. Nope, don't need absolute value. Okay? Even, odd. Nope, don't need absolute value. And this one, even, so you don't need absolute value. Okay? Either way, even if you wanted to attempt these absolute value ones, you still have to know how to simplify. Okay? So you're still doing all the simplifying like you did before, either using the factor ladder or the factor tree or whichever method you like. It's just all a matter of your final answer, you know, absolute value or not. Okay? All right. So, common powers that you should become familiar with is on the back of your notes. I think it's on the last page. All right. So, not saying you have to memorize this, but if you do memorize it, your life becomes a little bit easier. You will, if you memorize it all, sure, I'll give you a gold star. Okay? All right. So, yeah, listen, I have gold stars. I'll give you a gold star on your assignment sheet. Okay, so to the 3rd power, 4th power, and to the 5th power. Some of those are worth knowing, but it's there as a guide for you, okay? All right, so let's try some problems with variables. So let's go back.
Talk about a way to use the sensor.
No, this is an easier one. All right. So when you have numbers and variables, just take it one piece at a time, okay? All you need to do. Just take it one piece at a time. So I'm going to start with the number. What is the square root of 16?
4.
4. We know that. So then the 4 just comes out, okay? So then now let's look at the x's. How many x's are inside?
8.
8. What is your root here?
2.
2. Okay. So I'm going to show you 2 different ways here because I think some of you guys will see the shortcut way a little bit better. So I'm just, you know, write it all out. Square root, you have 8 x's inside. How many do you need in the group to come out?
2.
2. How many groups of 2 do you have?
4.
Do you have any left over?
No.
No. So, right? Okay. So now let's go over to the y's. How many y's do you have inside?
12.
How many y's are inside? 12. And how many do you need in the group to come out?
2.
2. Do you need me to draw all the y's?
No.
Okay. So, yeah, listen. Y times 12. Okay? All right. So that means when you do your groups, you should have
6.
6. Do you have any left over?
Mm-mm.
No. So then this is your final answer. Okay? Now I'm going to show you the shortcut way. Yeah. Nope. Because there's nothing left in the square root, you don't have to write the square root. Okay? So over here, you see how it says shortcut?
Mm-hmm.
It says blank the exponent by the index. That's how many come out. The remainder stays inside the radical.
Divide.
Divide.
I'm psychic.
That's what you're doing. Okay? So not the numbers. This is just the exponents. So square root of 16 is 4. 8. 8 divided by 2, that gives you a perfect 4. That 4 goes with your x's, yeah? 12 divided by 2 gives you a perfect 6. That goes with your y's. That's another way to do that, okay? All right, let's try the next one. So now we have a cube root. Remember, we're looking for groups of 3, okay? Cube root of 81. Is that a perfect cube?
Yeah.
No. So 81, okay? Some of you guys like the factor tree. All right, well, let's think about the factor tree. And you know, I think it's better if you guys kind of think about numbers, like bigger numbers, so that you're not sitting there drawing out every single factor. 81 is 9 times 9. Do you agree? Okay, but we're not out for square roots, we're out for cube roots, right? But 9 can be broken down further into 3, 3, 3, 3. Do you agree? How many do you need in a group to come out?
3.
Yep. So here we go. One of the 3's comes out. One stays in. And you know what? Leave yourself some room because you have a bunch of variables that you also need to account for. Okay? So just give yourself like a answer space and do your work like a little bit away from that. So now let's look at our A's. How many A's do you have? 6. You need groups of 3. So if I did my shortcut, 6, so over 3, right? What is that? What'd you say? Yeah, A squared. Do we have a remainder or anything left over? No, it's a perfect 2, so A squared comes out. Yes? All right, so now how about the B's?
We've got 2.
11 divided by 3? Oh, that's not
B
going
to
to be
the
it.
second outside, and then B to the fourth inside.
Second? You sure? Hold on, look.
Yeah, 'cause
11 divided by 3 is what?
wait.
What's the closest? Can't be 4. 3 times 4 is 12. It's bigger. 3.
Oh, look.
3 times 3 is 9. What is that? Remainder of what? 2? Okay. So this one comes out. Remainder goes in. Does that make sense? No? Draw it
So
out.
then B to
Draw
the
it out.
third.
I would draw it out. So B cubed, B squared. And you know what? That one's a little bit weird. I'll draw it out. Oh, out of the radical and stays inside the radical. So, I mean, really, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 3. And you need groups of 3. So 1, 2, 3. And then you have the 2 inside. Okay? Listen, guys, you can use either way. It's fine. Okay? You may start off drawing them out and then go, oh, wait, one day it clicks. Good. It's fine. Okay? So you have these 3 that come out, and then you have the 2 that have to stay in. All right? And then that's it. That's all for my variables and my numbers, so that's my answer. I know it's a little bit far apart, but it's okay. All right? Yeah. You want to write it closer together? That's fine. Yeah. Oh, nope, I can't even move it. Nope. Yep, nope. There we go. There. Nope, that's as close as I can get it. Okay? My computer's a little bit weird right now, so I can't mess with it. All right. 7th root. Oh, 7th root. Okay. That means I need groups of 7. All right, so I have negative 128. Guys, remember what I said? If you have a negative number inside, but your root is an odd number, you're going to get a negative, okay? If your root is an even, that's when you're going to have like i's and stuff, okay? But it's a negative, okay? So 128, you know, all right, so yeah. I'm just going to ignore the negative for right now. I'm just going to do 128 because I don't want the signs and stuff to mess you up. 128. Let's break this down. You want to use the factor ladder?
Mm-hmm.
All right. 2. And then what? Got the balance.
64.
Uh-huh. And then 2. 2. 2. 2. And then when you get to 1, you stop, yeah? So you need a group of 7. 1, 2, 3, 4, 5, 6, 7. Oh my goodness. Look at that. Any left over?
Mm-mm.
No. Then everything just comes out. Then you just have, then that just means you don't have any numbers that are still inside the bracket. So then 2, but we said this is a negative, right? Negative 2 comes out. Okay? And then I'm going to leave some room. I'm going to put 7th root. Okay? Just because I have these other variables that I need to do. So, x to the 7th. Guys, you have, yeah, good. 7 x's inside. You only have one group of 7.
Y stays inside.
And then what? The y?
Yeah, it stays inside.
Why does the y stay inside?
Because there's nothing for it to be in the
Yeah, yeah, because you don't have 7 y's. You just have the 1, so it has to stay inside. Good. And there you go. Okay. Please make sure that you write that root there. Okay, because if you wrote this as negative 2x square root y, that's a whole different problem. Okay? Guys, your heads down. Wake up. This is a pretty important lesson. Mini quizzes almost every day. All right, so let's look at this one. What do you do if you already have stuff on the outside? We'll just leave it for now. Anything else that you bring out, you're going to multiply with it. Okay?
Oh, yay.
All right, so 3xy squared, I'm going to leave it for now, and I'm going to look at my 4th root. So 256. 4th root of 256 is what? Break it down. All right, 256. We'll do the factor ladder. 2 what? You can do 16, 16. Then you know what? You break it down that way. I'll do this, and then we'll compare. What'd you say? 128? And then? And then? And then? Yeah? How many do you need in a group to come out?
4.
4. 1, 2, 3, 4. 1, 2, 3, 4.
Perfect.
All right, perfect.
2 times 2.
2 times 2, which is
4.
4. Okay.
4 times 2 is 12.
And remember, this guy, this is just waiting, okay? I mean, I guess I could write it down now, but we'll just write it down a little bit, all right? All right, so we have the 4, and then now I'm going to go and look at my x's. All right, so x, I have 21 x's, and I need groups of 4. So think about it.
5.
Yeah, you can get 5 groups of 4 because that's 21 divided by 4, which is 5. 20. You have a remainder of what? 1. So that tells me I have x to the 5th and 4th root x because that's x to the 1st, right? Are we okay with this?
Yeah.
Mm-hmm.
Is anyone lost?
No, I don't think so.
5, because if you have 21 x's, you can get 5 groups of 4 because 5 times 4 is 20, and then but you still have one more left over because there's 21 there. Okay. And then now what about 30 for the y? Yeah, so let's see. 30
7.
divided by 4, and you know if you're not really good at division, you can do it this way. 30 divided by 4. What's that whole number? 7. Okay. So then I have 7. 7 times 4 is 28. So I have a remainder of 2. right? So then I have y to the 7th, and then inside I have y squared. Oh. Right?
And then you multiply
Alright.
it.
And then, remember all the stuff that was here in the beginning. Now bring these guys down. Okay? So I have
12.
3x, y, and y squared, right? Multiply them. 3 times 4 is
12.
12. Yeah. X to the first times x to the 5th
6.
is x to the 6th.
Y to the 14th.
And no, y to the 9th.
I
When
thought-
you,
Oh,
yeah,
that's
when you
right.
multiply, when you multiply, what are those? Bases? Bases with exponents, then you have to add the exponents. Okay?
Okay.
And then just bring down these guys, 4 through x, y squared. Okay? Questions? Alright. Lily, you good? Huh? Alright, let's try another one. Okay, so with this one it says, write the following expression in 2 different ways. The reason why we're doing this is because I believe on the SOLs one year they did ask for this. They asked for 2 different ways, or they presented it in a way like, you know, circle all the answers, and they wrote it in 2 different ways. All right? So that is the expectation. You have to, just gotta know. So, all right, so the 2 different ways. Okay? Let's simplify this radical, just the way that we've been doing. Square root of 121, x to the 12th, y to the 7th. Right? One thing at a time. What's the square root of 121? 11.
Wow, I never did that one.
Yeah, I mean, you could even put that in the calculator.
Mm-hmm.
X to the 12th, what is the square root of x to the 12th?
Divide by 2, it's 6.
Yeah. If you have 12 x's inside, how many groups of 2 can you get? 6. Okay, so now let's look at y's.
You can get 3.
If you have 7 y's, how many groups of 2 can you get?
2.
3. But you have some left over. 1 left over, so that has to go back inside. Good. And so that there you go. That's it for that one. This one is the radical form. Yeah, that one was pretty easy. So we're going to talk about the other form that you need to know. And that's just basically writing it as a rational exponent, okay? 121. You just take it one thing at a time like we were doing before. Start with the number. What's the power on this 121? 1. Power over, what's the root? 2. And then x to the, what's the power on the x? What's the root? And then y. What's the power? Over a root. Okay? Write it like that, and then see if you can simplify it even more. 121 to the 1/2 power. I mean, you could easily put that in your calculator, but we know what that means. Square root of 121, which is 11. X to the, what's 12 divided by 2?
6.
Can you simplify 7 over 2?
Y to the 3rd.
Like, can you simplify the fraction?
Yeah.
No.
No?
No, that fraction is already simplified, so then you just leave it like that, okay?
That's annoying.
Well, because this one is written as a radical, so you have to do all of that, but this one is just written as a
That's
rational.
going to get really confusing.
Well, you know what? If you're just seeing it right now for the first time, we'll get more practicing. Okay? Oh, good. So these are the 2 different forms. Any questions?
Do we have a nap time?
No.
Shut up.
Here's what you should have. Radical form, And rational exponential form. I just put exponential, didn't I? Sorry. Rational exponential form. Okay? I know a lot of you guys are saying this is hard, it's weird. You know what? It'll get better. No, no, of course I care. Listen, it'll get a little bit better with some practice.
You promise?
Yes.
Okay.
All right. Here's the good news. The next part, easier than this stuff. Okay. All right. All right. So the next part is looking at solving. And you know, whenever you're solving, you're basically trying to get the variable all by itself, right? So here's the thing. If your index or your root is even, okay? So like
Always
square root,
odd.
fourth root, sixth root,
It's
right?
always gonna end up odd.
Then the answer always needs a plus or a minus,
How does that happen?
okay? Because you're solving now, you're probably gonna put,
Even.
but if your index is odd, okay? So cube root, fifth root, seventh root, right? Then the answer never needs a plus or minus. You don't have to do that. The sign, it just matches whatever your inside number is. If your inside number is a positive, then your answer is going to be a positive. If your inside number is a negative, then you need to bring out the negative. Okay? Well, we've already talked about that in a previous problem. Okay, so let's try some examples. Okay, so number 21. All right, we need to get this x all by itself. So, I'm going to add the 5 first. Then we have x to the 4th equals 48. Yes? How do you get rid of a 4th power?
Fourth power 48.
So you 4th root,
Fourth side.
right? Wait, what kind of root is this? 4.
4.
4 is a what? Even or odd?
Even.
Even. If it's an even, you have to put plus or minus. Okay? Just like whenever we drew the square root, right? We had to put plus or minus. Okay? Even roots. So then those cancel out and we have x equals plus or minus 4th root of 48. We're gonna have to simplify. Huh? 2 4th root 4th root 3. Okay, well let's see. 48. So 48 is what times what? 6 and 8. 6 is 2 times 3. 8 is 2 times 2 times 2. All right, just did a little shortcut there. Are we okay with that? We know 2 cubed is 8, right?
It's 4.
4 times 2, which is 2, 2, 2.
No, there's 4 twos.
Okay, so we need a group of 4. 1, 2, 3, 4.
We can pull that out.
Yup. So then the 2 can come out. What happens to this 3?
Stays on there.
Stays inside. So no, I wrote it over there, but I'm gonna write it over here too.
Why'd you
Plus
put-
or minus 2 4th root 3.
Why'd you write it the way that you did? Like right next. You didn't do it equal to the plus and the minus. You did it equal to the negative. Why?
No, it's just I just wrote it a little bit crooked. There. A tough crowd.
It wasn't
It's okay.
symmetrical.
No, you know what? I do need to be neat about it. All right. Yes. All right. Let's try the next one. So the next one, I need to solve for x. But I need to get x cubed all by itself first.
Divide by 5.
Divide by 5. Good. X cubed equals negative 125. How do I get rid of that cube?
Divide.
Cube root. Cube root. Guys, do I need to put a plus or minus? No, because this is an odd number root, right? So those go away, and I have x equals, but wait a minute, it's a negative number inside. So my answer has to have a negative. Well, what's the cube root of negative 125? The 5. Okay, we will. All right. Number 23. What do I need to do first?
Divide by negative 1.
Good. Divided by negative 1. Then you have x
What are you
squared
laughing
equals
at?
negative 1. Right? Then what? How do you get rid of the square?
Root 2.
Square root. Guys, plus or minus? Yes. Square root. So x equals plus or minus, what is the square root of negative 1? Pi. Alright. Alright, so number 24. Alright. So with this one, subtract the 7 first, right? Negative 2x to the 5th equals negative, what is it, 64? Now what?
Divide by negative 2. It's negative.
Divide by negative
32.
2. X to the 5th equals what?
32.
32.
No.
So,
Oh,
you're right.
yeah, it is.
5th root. Guys, 5th root, do I need square root? I mean, do I need plus or minus? Sorry.
No.
No.
It's odd.
It's an odd. X equals
2.
2. 5th root of 32 is 2.
It's a magical number.
Okay. And you know what? For the smaller ones, hopefully you guys start like memorizing some of them. But if I were you, I would check it in the calculator and see if it gives you a nice pretty number. Because don't use up all your brain power unless you have to.
How do you use 25? It's got parentheses.
What do you mean?
It's got parentheses.
Okay, let's do the next one. Number 25. Alright, number 25 is very important. Don't pack up. So I'm going to add 3 first. Then I have parentheses x minus 4 to the 4th power equals 256. So get rid of that exponent before you try to do anything inside the parentheses. How do you get rid of that power of 4?
Root.
What?
Fourth
4th root. But guys, 4th root, do I need a plus or minus?
Yes.
Yeah.
Because it's an even. So then that cancels out, and then you have x minus 4 equals plus or minus. What's the 4th root of 256?
I don't know.
4. Okay?
It equals 8.
And then you add the 4. Alright, so pay attention to this, okay? If you already have a plus or minus over on the other side, and you're adding or subtracting something over, this guy has to go in the front. And you need to make sure you have 2 answers, because this is a plus something and a minus something. So this is x equals 4 plus 4, and x equals 4 minus 4. So your 2 answers are 8 and 0. Does that make sense?
Magic.
Alright. What would you do first here?
Divide by negative 1.
Good. Divide by negative first.
Is it okay if we pop
Alright.
off or are you going to chop off our heads?
Alright, so any questions about this? You guys feel okay? Everyone has